can still be felt across the country. Thousands of homes still without power. Network Rail says they're working tirelessly to clear debris off train lines, while SSEN say they're working to restore the 22,000 homes still without electricity. Keith Bell, Professor of Future Power Systems at the University of Strathclyde and a member of the Climate Change Committee, is with me now. Hello, Keith Bell.
Hello, how are you doing?
I'm well, I hope you are too. This thing about, do we cope well with these kinds of weather issues, given we need to supply power to people in country areas?
Well, I think we're doing better than we did. I mean, it's an unfortunate truth that these sorts of storms are happening more often. So in a sense, the network companies are getting more practice and should be getting better at understanding how to do them. I mean, to have a storm like this at this time of year is very unusual. It's kind of almost unprecedented to have such high speeds while we've still got leaves on the trees, so which then, ends up with a lot more damage being done. But I think things are getting better. I mean, it's of course never ideal if you're one of those, tens of thousands of people that's still off supply after a day or more. But the information that's provided, I think, is getting better. There was certainly the network companies were criticised a lot back. I think Storm Arwen was November 21, I think it was, and the regulator for the electricity sector, Ofgem, was quite critical of quite a lot of what the network companies were doing and had done. In particular, the information provision. For example, how long are you likely to be off supply for? Because you need to know so that you can try to plan and make arrangements. Family members or neighbours can look after people who are a bit more vulnerable, but only if they know they need to do it.
Yeah, which is assuming we're going to lose power to some people. What would we have to do to not lose power, and would that be cost effective or not?
Well, unfortunately, especially when you get outside of the cities and the towns, to build a network connection, to have that kind of redundancy, multiple connections, or to make the connections much more sort of robust, would be very, very expensive. For example, people talk about undergrounding everything, but that would be 5 to 10 times the cost. And although faults wouldn't happen as often, you still have problems, kind of electrically or some damage being done. And it's a lot harder to find and repair the faults. And one of the kind of upsides, I suppose, of the overhead lines is you can see where the problem is. And if you can get there, and this is one of the problems with a storm like we've had, debris across roads, just getting access is very difficult. But once you get there, you can do the repairs relatively quickly. Reducing the kind of likelihood of having a disconnection becomes very expensive. So the priority then, I think, is when it happens, is to get supplies back as quickly as possible and to make sure that the information provision is there.
Ah, right. You're saying the cost-benefit analysis would say it's not worth undergrounding everything, but we are getting better at responding to this. Given that it's becoming more prevalent, we're getting better at coming back and fixing this. Is that what you're saying?
Exactly. Right. So, having the weather forecast that it was going to be as severe as this was critical in terms of getting the people ready in the right sorts of places with the right sorts of equipment, to be able to get out and do the repairs as and when the need becomes apparent. They would have been bringing in people, on standby, including, even people who would have been doing kind of office jobs who've still got that sort of authorization to get out in the field, get them there and ready.
Before you go on, just briefly, do we just have to accept that given, you're on the Climate Change Committee, that given climate change, this is going to happen more often?
Yeah, the frequency of extreme weather does seem to be increasing. I'm not a meteorologist, so I can't speak with expertise on that. But what I understand from colleagues is that the increased air temperature means that there's a lot more moisture is held in the atmosphere, and when it comes, and then you get sort of the extremes of air pressure, which lead to the very high wind speeds, and then when you get storms, it's a very high rainfall in a very short space of time, and then multiple storms happening in quick succession. So you've already got, for example, saturated land, and then another storm comes, and that makes it much more likely that you'll end up with flooding. And if the land is wet, again, it's sort of weaker and more likely that land will subside.
Keith Bell, thank you, Professor of Future Power Systems at the University of Strathclyde.